Hi, I'm Eric Edelman, your host, and welcome to Down to Earth. I so much hope that you enjoyed that absolutely incredible rendition of a very special part of the Planet Suite by Gustav Holst. And this was played by the U.S. Air Force Heritage of America Band. It's an absolutely beautiful rendition. And this suite, the Planets is what it's called, is an orchestral suite in 7 movements. We have 8 planets, but just seven of them are included in this piece, the one that's excluded being Earth. And so each movement is dedicated to a very particular planet. And this particular movement that we just heard, it was absolutely boisterous. It was epic, cheerful, and a little bit, might I say, larger than life. Earlier this evening, we went to the moon on Slooh. And now, through those very same Chile telescopes, we're going to go live to a planet whose suite we've just heard, and that's Jupiter. And since this is a down to earth show, it's a show about how the universe affects and impacts us. And we're going to talk about what would happen if we lived on Jupiter or in its neighborhood, about what would happen if we experienced that incredible planetary personality up close. And so the biggest planet in our solar system is hogging up the spotlight tonight as we go down to Jupiter. And here we see it live on our screen. This is Jupiter from the Chile telescopes, from the Slooh Observatory. And now, as we're looking at this amazing object, and as we get further and further into more detail about what it all means, if you have any questions during the show, you can use the chat box to talk right to me if you're watching this live. It's happening, Tuesday evening, 9 p.m. Eastern, 6 Pacific. And so this chat box is on Slooh. It shows up either to the right of the show or a little bit below it. You just scroll down a little bit, depending on your browser. And I'll be checking this chat occasionally throughout the show, and I'd be happy to bring your questions or commentary into the show whenever I can. Consider this an absolutely collaborative effort on both of our parts. And so, yeah, Slooh Tech is actually mentioning a very interesting thing that will happen live during this show. I'll be talking about that very soon. There's a lot of dynamic things that are going to be happening here. And so let's take a little bit of a closer look at this live imagery, see what we're working with here. And so we see Jupiter right now. And depending on the size of your screen, it can't seem that much larger than some of the change that maybe you might be carrying around, say, in your pocket. And this smallness, it doesn't speak so much to the size in real life of this object, but just how profoundly far away from us that it is. And depending on where Earth and Jupiter are in their orbits, Jupiter tends to be somewhere between 4 and 6 times the distance from Earth than Earth is from the Sun. And we're talking about multiple hundreds of millions of miles. This is a huge, huge distance, yet we still see it as this significant largesse in our telescopes, while most other objects at this distance would show up as mere specks of light, if anything at all. Jupiter is big enough to really be seen. And at its actual size, it can fit over 10 Earths across its whole belt. It's a really huge object, and is by far the largest planet in our solar system. We have a wonderful, I believe, comparison of what Jupiter looks like compared with Earth and with the Sun as well. There's a huge variation there. Like, oh yeah, there it is, where we see the moon itself. There's a few moons that can fit into our Earth, but then that Earth itself, a large amounts of it can fit into Jupiter. And the amazing thing about Jupiter is it's really the only planet that is really in any way comparable in size to the sun. We see that quite a lot of Jupiters fit in the sun as well, but it is one that stands a little bit more than a chance than when compared with the rest of the planets. And so that's just to give you an idea of just how huge this object is. And so it is certainly, by and large, the largest planet in our solar system. And so now, as we're looking at this object live, do you see a dot or two surrounding Jupiter? Now, those are some of its moons. And so these might be a little hard to see because I was talking about earlier, things that aren't quite as big as Jupiter, they're not going to show up quite as bright. But right around sort of the 2 o'clock region on Jupiter, a little bit up and to the right of the planet, you should see a dot. And that dot is the moon Io. It's one of the Galilean moons of Jupiter. There's around 67 moons of Jupiter. There's a lot of moons, but there's 4 ones that are really big, really significant, sort of comparable in size to our own moon. And those are the ones that Galileo observed hundreds of years ago to learn so much about this system and about the way our solar system works. And so this moon is actually going to do some really cool things in particular. Oh, there we have a great circle on it there. And so Io, in the middle of this show, is actually going to head behind Jupiter. Jupiter will eclipse Io in our view, giving us proof that this system, these aren't just dots in our screen that are stationary. These are things that are moving. This is a system that is dynamic. This is something that changes constantly. And for that very reason, can bring about a lot of interesting things in terms of habitability and things like that that we'll discuss as we go through the show. But look forward to that. You see this dot now, but you won't see it a little bit later. And so I'll be letting you guys know a little bit later on in the show when the dot should be disappearing and we can see that feature actually happen before our very eyes. So, all at once we'll see this dot. We'll see this dot on the screen disappear, giving us a little evidence that the system that we're viewing is in motion and action. Like, how exciting is that? And so we see the system full of activity and excitement, but what would happen if we went up close and personal with this gigantic planet? Uh, what would happen if we tried to go down to Jupiter, say? So we actually have this amazing visual of sort of the ins and outs of what Jupiter is. We see Jupiter's very top clouds when we look at it, and that's the top part of the planet, the part that isn't cut away here right now. And we see this swirling storm of the Great Red Spot. That's one example of one of the things that we see. And this spot itself could easily fit 3 Earths inside of it and has been storming for hundreds of years. So first off, we get to know that this atmosphere, just the very top of the planet, is absolutely intense and composed mostly of hydrogen and helium. It's terrifyingly chaotic. Storms can last much longer than humans can live. Generations would go by and those storms would still be raging. And then these storms themselves, they stretch to regions further than our entire planet could cover. That amount of magnitude is pretty crazy. So it would be an eventful lifestyle if we decided to put our space bungalow on Jupiter. We know that initially. So if we could handle that, if we had a really strong space bungalow, where exactly would we put it? Where is some ground to stand on? So let's consider what we know about the insides of Jupiter. And this image is wonderful to display sort of what we know about that. We have that top cloud layer, which, talking about that storm, the Great Red Spot, that thing that we see, the moving bands of clouds. And this stuff extends about 50 kilometers or 30 meters deep. It's actually not too deep when you consider the whole planet. But the whole atmosphere of Jupiter itself, that goes about 100 times deeper than this. So 30 miles or 50 kilometers times 100, that sort of deal. That's how far the whole extent of the atmosphere goes, way deep into the planet. And this is including some hydrogen gas and also deeper in to the planet. When it gets a little bit hot enough, that hydrogen gas turns into hydrogen liquid. So below this atmosphere, this huge atmosphere, do we get any ground to stand on? The answer is no. At this point, there is a huge, thick, enormous sea of metallic hydrogen. That's sort of the pinkish area that we see right there. And at the top of this sea, the temperature is around 17,000 degrees Fahrenheit or 9,700 degrees Celsius. And that's pretty crazy. But where the metallic hydrogen, this pink stuff, gives way to the rocky and icy core in the center, that's when this temperature gets up to about 64,000 degrees Fahrenheit or 35,000 degrees Celsius. So yeah, usually the deeper you go in Jupiter, the hotter it gets. And it can get really, really, really hot. Jupiter may be far away from the sun when compared to the inner planets, so it's not getting as much of that sun's heat, but as a giant ball of pressurized gas, it gets pretty hot all on its own. Some severe hot temperatures happen. But even with this, with the crazy storms and the metallic hydrogen above us and the tens of thousands of degrees of temperature baking us, is this the place right on top of the core where we'd have someplace solid to build our space bungalow? Is this the place? The answer is still probably no. The core is pretty deep inside the planet, so it has been hard for scientists to tell, but many of them think that the core is probably not solid. Instead, it's likely a super hot melted core, so things continue to be crazy no matter where in Jupiter that you are. Now, I'm not even really going to go into much detail about what the pressure's like down there, but just consider, deep in Jupiter, it can get hundreds of millions of times worse than what our atmosphere on Earth pushes down on us every day. So there's also that to contend with. So considering all these things, what we know and what we don't, on actually July 4th, estimated of this year. The Juno spacecraft will be reaching Jupiter and start orbiting and studying this planet in unprecedented detail. And maybe this will give us a little bit more insight into some of the mysteries surrounding Jupiter's deep innards. So maybe we might be proven wrong. Maybe the core will be solid. Maybe there's some place to put that space bungalow. We're working on it. We're still trying to figure that out. So, okay, we can't stand anywhere, as far as we know, on this hot and stormy and gassy planet. And there doesn't seem to be any place that's particularly hospitable to float around either. These storms are crazy. However, this does not mean that we're entirely out of luck with the Jupiter system. So let's talk a little bit about those Galilean moons of Jupiter. This includes Io, this includes Europa, Callisto, and Ganymede. And so in terms of switching back to the live imagery, we're going on our countdown as we speak to the eclipsing of Io. And I believe it's about to happen. Either it has happened or it might happen any minute now on our live imagery. I'm trying to look hard at Jupiter. I don't think I see it. Checking in there. I believe it has happened. So this is it, folks. We have seen Io be eclipsed by Jupiter. And just in the span, I've just been talking for about 10 minutes here. In the span of 10 minutes, we have seen a moon go behind a gigantic planet that is, 4 to 6 times more distant from us than the sun is. We've seen how dynamic and how much in motion that our solar system is. That's absolutely incredible. And yeah, there's some great advice here in the chat box because this moon was a little bit hard to see. And if you see it later in the night when it comes out behind Jupiter, this is great advice, is that you increase the resolution on your screens. View the feed in 720p. That should really help you out. So thank you, Stephen, for that advice. That's absolutely a great idea. But now we don't need the 720p necessarily. It's great if you want it, but we don't see the moon anymore. And that's because it is now behind Jupiter in our view. We have seen evidence of how dynamic that this solar system is. And speaking of orbits, that's actually where we're going right now in terms of the topic. There are some really fascinating things going on with the orbits of these moons around this giant planet that could spell out really intriguing things in terms of their possible offerings for our space bungalows. Io's orbit, the time it takes to get around Jupiter, the length of its orbit, is half of Europa's. It takes Europa twice as long to get around, and it takes Ganymede twice as long as Europa. And so this means that those planets, they often line up and tug on each other. Here's this great animation of it. So we see these planets, they line up on the same side of Jupiter a lot. They have this orbital resonance with each other. And so when they line up like this means that they tug on each other when they get close enough. And this tug of war, it stretches and it heats the moons, which means that temperatures can potentially get high enough for interesting things to happen, even though these bodies are so very profoundly far away from the sun. So let's talk about what this means in terms of Europa in particular, which is just slightly smaller than our moon. We have a great comparison of that as well. And it's the smallest of the 4 big Galilean moons out there around Jupiter. And so it's in terms, oh, there it is. Yeah, so see, Europa is really, it's a little bit smaller, but it's pretty close to what our moon looks like in comparison to Earth. And we've been on the moon. We've seen it's reasonably big. Like, hey, maybe one day we might put a moon base up there. And so there's room on the moon. So there's room on Europa if Europa has the right kind of qualities that we're looking for, potentially. And so what is Europa made of? Well, the moon actually, it has a metallic core. And that metallic core is surrounded by rock. And here we see a visualization of that. This is visualization based on data taken by the Voyager mission, and it's pretty cool. So on top of this rock, that's where things get really, really fascinating. It's possible that Europa has a saltwater ocean that is being kept warm by all the stretching going on from the tugging of Jupiter and its neighboring moons. And perhaps, just perhaps, this could be a place for our space bungalow. We could put it at the bottom of the European Sea and create a mini Atlantis down there. That's just my thought. However, and there always seems to be a caveat with this stuff. One issue that we would have to deal with comes from the planet that we couldn't quite live on. So we gave up on Jupiter a little bit earlier in the broadcast, But Jupiter's inhabitability might be a little bit contagious, unfortunately. And this is because the planet has an extremely strong magnetic field. And this magnetic field is accompanied by an array of dangerously strong radiation belts. That's what they're called. Earth has similar radiation belts, and these are known as Van Allen radiation belts. But in comparison with Jupiter's radiation belts are about 1 million times more intense than the ones that we have on Earth. They emit a lot more radiation, and the radiation travels really, really far. The effect is so intense that someone standing on Europa, on the surface of this planet here, which is about twice as distant from Jupiter as our moon is from Earth, they would get about 540 rem worth of radiation in a day. And that is a pretty fatal dose. You do not want that. In a few days, you're not going to be around anymore if you receive 540 rem. However, we don't need to be on the surface. That's where this ocean comes in. We can be underneath the surface. The European Sea is actually covered by a thick surface of ice that could help to block out most of the radiation. And so humans could stay in their space bungalows under the icy surface that's getting hit by the tons of radiation, but it's not getting through. And they're going to be hanging out in the warmer waters below that are hopefully heated by all this orbital resonance, the stretching, and the tidal forces. So there is a possibility. It's not quite Jupiter, but it's close. It's in Jupiter's neighborhood. And with this potential livable ocean available to colonize, one has to wonder if we'd be sharing this space with any locals, so to speak. In looking for places for ourselves to live, we might scout out some places which have already found that life has already had a foothold there, that doesn't belong to Earth. Now, certainly, this would not be one of the easiest corners of the solar system to colonize, but it can be intriguing to consider some of the more off-the-wall possibilities. Do you have any thoughts yourself about unique places that maybe we could explore in terms of considering whether we could possibly set up space bungalows there? Like, let me know in the chat. I'd love to hear your thoughts on that as well. But we've covered a lot during this show. We've seen an eclipse of one of the moons. We've talked about the habitability of Jupiter and some of those moons, and considered a lot about this solar system, or this particular planetary system. And it's been great to see it live as it happens. So we get this sense of immediacy and the sense of motion as we're considering these objects in our heads and our imaginations. We get to touch down on Jupiter in some ways as well. And so it's really intriguing stuff to think about. And as we're wrapping up this subject, if you have any more thoughts on the subject yourself, if you have ideas about other places to colonize, if you have ideas about living on Jupiter or one of its moons, I'll be around in the Slooh chat box for a while after the show to chat a little bit about what we've been talking about, what's been going on here. We can't necessarily explore all these places physically right away, but we can indeed explore them in our minds. And that is so much of a fun exercise, I can't tell you. So thank you so much for tuning in this evening and for hearing me ramble on about habitability on Jupiter and Europa and what all that could mean. And I hope so much to see you again next week, same time, same place for Down to Earth. This has been Eric Edelman. I hope you have a good night.